Well, thank you for coming to this talk called JavaScript in 2016. My name is Edu, and probably you are asking, who am I? Okay. First of all, I'm a beer lover and crafter. I proudly have to say that nobody died after drinking my beers, so that makes me very happy. But also, everybody refused to pay after drinking it. Okay. I'm also a happy and a proud father of a little 4-year-old earthquake. Also, I'm a speaker. I'm in conferences speaking, conferences like CodeMotion, but beers and speak don't give me any money, so I have to work. Thing that I do happily in Plain Concepts, which is a Spain-based consultancy firm that we are specialized on building solutions using web and Microsoft technologies. Okay, just for the curious, I'm this guy. Okay, I'm from Igualada, which is a small city near from Barcelona, and I'm very happy to be here and talk a little about JavaScript. What we'll see in this talk, well, we'll talk about JavaScript, how it was, just a brief recap, how it is now, and the brief outlook about some new upcoming features that we may have in the language in the future. I give this talk several times, and every time that I need to talk about JavaScript, new features, ECMAScript 2015, I have the same doubts, how to organize the talk, how to introduce the topics, which topics introduced to be sure that they will be fit in a 40 minutes talk. And for this talk, I will do a new thing. I will start by the last slide. This used to be the last slide of my talks about JavaScript, and is the most important thing that I want you to remember from this talk, which is there are no excuses to use ECMAScript 2015 right now. In fact, you need to start to using it. If you don't use all new features, you will be out of the game very soon. All new frameworks, libraries, and everything assume that you develop with these all new features. Okay. Most features are already implemented in current evergreen browsers, so get Firefox, get Chrome, and just start playing. Most of its features are implemented, and for the rest, we have a transpiler, so we can get ECMAScript 2015 code, compile it to ECMAScript 5 code, and run on every browser. And while preserving a full debugging experience. So we can debug using the developer tools. We can debug against our ECMAScript 2015 source code, even though the browser is running the transpiled ones. A bit of history, JavaScript is 20 years old, so it's not what we call a new and modern language. Currently, it's in 6th version. Really is the 5, because there was one version which was number 4 that never released, was a very, very, very ambitious version. And I think that the market, developers, browsers, and so on were not ready for version 4 when it was designed. In fact, some of the features of version 4 are not still in version 6, or won't be in version 7 also. So that is for you to realize how big was the scope of version 4. Was too big that finally failed, then released version 5 in 2009, which is the version that most people use, but really a lot of people don't use all of these features. So every time that I go to customers to review some project or do some consultancy about JavaScript, I see once again and again that are a lot of features, a lot of current features of version 5 features that are underused a lot. Getters and setters, still a lot of people don't know that JavaScript has properties with a getter and a setter, and just use plain variables and stay with that. A strict mode, which should be mandatory for every JavaScript developer, is very, very, very strange to find it. And all APIs about reflection, so inspecting in runtime the properties and keys that an object has. All these APIs are from 2009 and are still underused, so we need to start using them, and in fact we need to start using all of the new features that ECMAScript 2015 has, that are listed in this slide. We won't cover all of them because we will run out of time very, very fast. We will cover those that I think are the most relevant and could impact more in the way on how we program in JavaScript, which are arrow functions, iterators, generators, destructuring, classes, promises, and modules. These are, for me, the key features of the new version. We will iterate over these features, showing tips, code, and how these features could impact in your JavaScript code. And the goal of the talk is combines you how cool these new features are, and combines you to start using ECMAScript 2015. So let's start with arrow functions. Basically, ECMAScript has functions as a first-class citizen. That means that we can pass functions to functions, we can create functions inside functions, and we can create functions then return functions. That is the thing that we are constantly doing. We pass callbacks, we return functions, but syntax is horrible. It's very verbose. We need to do a lot of keystrokes to create a function. Arrow functions is just only basically a new compact and cleaner syntax to create your function. So instead of typing this, you can type this. A lot of languages have a syntax similar to this, and just is what it is. Just put the parameters, arrow operator, and the body of the function, and if the body of the function only is a return, you can omit the return statement and the curly braces. It is basically what arrow functions are. But they come with a gift, which is the context preservation. One of the hardest challenges for every JavaScript developer is really understand how this works in the language, because it has a very weird behavior. Okay. In fact, in this function that we have here, the value of this .name inside the function is not the value of this .name inside the brewery. And that is really a thing that's very strange for the developers, and it's because the way that this used to work. So a lot of developers do something like that, so it's binding the inner function to the value of this of outer function, and in this case, the value of this into the inner function is the same of the value of this on the outer function, which is the current object, which is what is expected. Some other developers create a variable and call that or self and made the typical code that you can see in JavaScript called var that equals this, and they start using that. It's by the same reason, but by using an arrow function, you don't need to do this anymore. You just can put your arrow function, and the value of this is preserved from the outer context. And that was my face the first time I saw that. So finally this works as it should be, as is expected, because the current way of this behave is, in my opinion, a design error of the language, and they correct it with arrow functions. But be aware of that, okay, because if you run this code, what you will get is that. For the same reason, for the preservation of value of this in the arrow function in the first example. If the first example, instead an arrow function, we use a normal function, the code behaves correctly. So we still need to understand some tricks about this in JavaScript. Maybe in the near future, this is a proposal not accepted yet by the committee. They are still discussing if this will be a good idea, and all the semantics behind that is the pipe operator. All of us that came from a functional language probably know that, because it's very used in functional languages like Elixir, or Camel, Haskell, F#, and so on. And instead of doing this kind of concatenating calls, we can write this code, which is very cleaner and easy to read. This is the pipe operator, that basically what it does is the return of the previous expression is passed as a first parameter of the next expression, and that will allows us to create code that is very, very, very easy to read. It's a proposal. It's only syntax sugar, but syntax matters a lot in my opinion. The syntax of a language defines how the designer of the language are thinking we will use the language. So having this kind of syntax is a path, is an indicator that the people that is designing JavaScript are thinking that a better way to use JavaScript is create a more functional approaching. Okay. Destructuring is a cool feature, okay, which basically is a mechanism for obtaining parts of an object and arrays and assigning them to individual variables. And if one of you is just thinking this sounds a lot like pattern matching, you are true. This is a kind of pattern matching in JavaScript, and it's very, very, very powerful. Let's see some examples. We have an array of 2 values. How we can assign these 2 values that are in array into 2 separate variables? We can do the standard way. Of course, it works, but we can use destructuring. These 2 sentences are exactly equivalent. The 2 variables on the bottom, x and y, contains 42 and 69. It also works in objects. So if we have an object with these values, a, b, and c, we can create 2 variables, x and y, and the value of x is the value of the property a, and the value of y is the value of property c. So we can extract partial information of the object and the store into individual variables with 1 sentence. Suppose that you have this object and you want to extract the name and the second beer of this array with only 1 sentence. You can do with destructuring. This sentence create 1 variable called name, which its value equals to the value of name in object user, and creates another value called epidor, which its value is the second, note the first comma, so it's the second value of the array called beers in the object user. So we can very, very, very easy extract parts of objects and the store into individual variables. And we can do this in values that are returned from functions and so on. So that gives us a way, very, very, very easy to allow or to create functions that returns more than 1 variable. The function just can return a standard object, and we can use destructuring to map the properties of this object to standalone variables. So it's a very cool feature. And we have also a new operator, which is the split operator, which are 3 dots, dot, and the split operator maps to the rest of values of an iterable. We will see the concept of iterable later, but for now we can suppose that is an array. We have an array of numbers, and use destructuring, so 8 is the second value, 15 is the third value, and others are the rest values. So 16, 23, and 42. So others is an array that contains the rest values of the lost array. Okay, so that is a very, very powerful operator, because that allows us to extract the rest of information that we have not extracted using destructuring. Also, a spread operator can be applied to an array. So we can use dot, 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 and an array. And if we do so in a function call, this will map the elements of the array to the parameters of the function. So if we have a function with 3 parameters and we have an array with 3 values, we can call this function just using f parenthesis dot, 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 and our array. And this will map the first element to the right to the first parameter, the second element to the second parameter, and the third element to the third parameter. Probably some of you are wondering why we need this, because we have apply, which basically do the same. Apply allows us to call a function, but passing the parameters using an array instead of passing one by one. But the spread operator is more powerful because we can do things like that, which are not possible using apply. In this example, A will be 10, B 20, C 30, D 40, and A 50. And that is a very, very powerful way to call functions when we have data that came from external sources and we have them into arrays. So it makes it very, very easy. It's nothing that we couldn't do before, but with the spread operator we have a very easy way to do this kind of things. Another new feature are the rest parameters, which if we use the spread operator in a function signature in the last parameter, this parameter will capture all extra parameters passed to the function. So if we have a function with 3 parameters and the last parameter is declared with dot, 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 and we passed 5 parameters to this function, the third parameter will be an array containing the third, the 4, and the 5. So it's like arguments that we have, but it's better. Why? First, because it's an array, is a true array, so we can use all functions that are in array.prototype. We can map, we can filter, we can do a lot of things with this array. It's not an array-like object. Arguments is not an array. In fact, the first thing that most people do with arguments is convert them into an array, because you want probably to filter them, mapping them, and so on. So that do this automatically, and contains only the non-named parameter. So in this case, the value of C will be an array containing 2, 3, and 5. That is what we call the rest parameters. It's capture the parameters that are that are not specifically named, and is never undefined. Never. So if we called foo with only one parameter, let's call that we call foo 1, only one parameter, A will be 1, B will be undefined, and C will be an empty array. So it always has a value, which is good. Iterators and generators are probably one of the coolest features, in my opinion, about ECMAScript 2015. Basically, an iterator is an object that allows iterate over the values of another object. That what means is that we can create our custom objects and make that our custom objects behave as collections. So we can iterate over the values of our custom objects, and we decide which are these values and how we can iterate over them. So basically, an iterator is a function that returns an object, which is the real iterator. The name of this function is symbol.iterator, is a special name, uses a new data type in ECMAScript 2015, which is symbol, is a special name, so we need to use this name. We cannot use iterator or whatever name, needs to be symbol.iterator. That is the name of the function that will return the iterator. Of course, we can only have one iterator per object. And the most powerful thing is the iterators are lazy evaluated. So only are executed when we start to iterating over the values of an object. Okay, and any object that has an iterator, so any object that has this function called symbol.iterator, is an iterable. And can be iterated using a new loop, which is for off. So we have for in, which iterates over the keys. We have the standard for, and we have for off, which allows iterates over the values of an iterable. So we can do for var v of my object, and in every iteration of the loop, v will be one of the values of my object, of my iterator. Creating, it's a bit cumbersome, it's a bit verbose. Why? Because we need to declare the symbol iterator as a function that returns an object with only one function, which is called next, and this function needs to return an object with two properties. One is called value, which is the current value of the iteration, and one is called done, which is a boolean that says if the iteration has finished or there are values yet. The code will be something like that. Fibonacci is a standard object, defines the function symbol.iterator, so we need to use the square brackets. If not use the square brackets, we have a syntax error, but just is a standard function. So we have symbol iterator, parentheses, curly brackets, and code, and the function returns an object with the function next, and in this case, we are using Destructuring to create the values of Fibonacci. And we can iterate using this kind of code. Is as Fibonacci were an array, as Fibonacci were a collection, but Fibonacci is a standard object with an iterator defined. Okay? And in every iteration, that is the code that is executed once and once and once and once until the iteration finishes. Creating iterators is hard, and most of us will use generators instead of iterators. A generator is a special kind of function that creates iterators, but creates they using a coroutine. So it's a function that yields values one after another, and everything that a value is yielded from the function, the code exits and returns to the caller, and when a new value is requested, the code re-enters into the function in the step they was and continue the execution until yielding another value. So it's a kind of coroutine which we didn't have coroutines before that in JavaScript. Okay, a generator that never stops yielding values will create a never-ending iterator. And that's no problem. We can create infinite collections with that because they're lazy evaluated. Of course, if we create infinite collections like that, so that it's an infinite collection, we need, and if we want to iterate over that, we need to break at some point, because if not, the code will never finishes. And that is how we can create a generator. Now the syntax is function asterisk. Asterisk means generator. That's a generator, and we see the code is pretty much simple. It's just a never-ending loop, and in every iteration of the loop, we yield a value. That's the only thing that we need to do to create an iterator. This code and the previous one are absolutely the same, so we can still do that. A good thing about generators is that generators can be objects by themselves. So we can do that, and we are creating a generator that allows us to iterate over these 6 values. We can use the spread operator to pass all these values of the generator to an array. So this is a kind of new possibilities that we can do with that. And the generator can include all the values of another generator in every yield. So they can do something like that. We have a generator called lost range, which receives a parameter. We have the previous generator that generates the 6 values. And in every iteration of the loop, we yield the index, which in this case will be 0, 1, etc. And we yield all the values of lost generator because we are using yield asterisk. It's important asterisk in yield so that will generate this set of values. 0, 4, 8, 15, 16, 22, 42, 1, and all the values of the previous generator again. So we can do a very, very interesting thing using generators and iterators. So basically the idea is we can create an object and we can make this object to behave as a collection. And as is an iterable, we can use the spread operator to convert them into an array if we want. and use all the array.prototypes functions to map, filter, find, whatever we want. Another feature of ECMAScript, not implemented in any browser today, it's classes, which is mainly syntax sugar, mainly. There are a couple of advanced scenarios that classes allow us that we cannot do today in ECMAScript 5, okay? But JavaScript is still dynamic, no static typing. Classes don't exist in runtime. Type of a class is function. Classes are basically a syntax sugar for declaring a specific kind of function, a constructor function. Okay? That is the basic syntax. Important here is the pseudo method constructor, which is called when we use new. We only can create objects of a class with new, so we only can do var p equals new point. Okay, that will run the constructor. We can assign properties to this, and we can define methods using this syntax. Just the method toString is method of the class point, so it will be available in all objects that we create using new point. Classes allows us to create properties using getters and setters, the same syntax as ECMAScript 5, nothing changed here. We have inheritance, so we can create a point3d extends point. That basically means that at runtime, a point object will be the prototype of all point3d objects. Behind the scenes, we still have prototype. Okay, nothing changed at runtime. Okay, we can have a static method. Static method is a method that is added onto the prototype and not onto every instance. And the constructor pseudo method that we saw before. And no private methods. We still don't have any syntax for declaring private methods, but we can fake them in the same way that we can fake currently private methods in ECMAScript 5. 3 ways. This is the ECMAScript 5 way to do the things. We use the constructor as the scope. We need to declare all the functions of the class inside the constructor and assign to this. In this case, the getDay acts as a closure, and we can access to the to the underscore day variable, which remains private. This is not recommended in ECMAScript 2015. This is how do the things in ECMAScript 5, but it's not the way to do it in ECMAScript 2015. Another way is to using symbols. Okay, this is just for reference. We haven't talked about symbols. You can create your own symbols. And in this case, due to a specific property of a symbols, which are that the one symbol never equals to another symbol, so every symbol is unique. Okay, we can assure that as day key is a symbol and it's private, nobody will can access to this property named day key, because day key is a symbol and is private, and nobody can create another symbol with the same value. So that is what is the, how it works. Okay, we need the extra functions simple day. Why? Because we need a scope for keeping private the symbol we are using. Okay, this is good, but really these properties are not truly private, because we have a new reflection method, which is object get own property symbols, which gives all the symbols that are used as property names on this object. So using object dot get own property symbols, we can still get these symbols and access to this property. So we need to have a better way, and we have it, which is using a weak map, which is the recommended way to creating private properties into classes. In this class, we create a weak map. A weak map is a new class in JavaScript, a new type in JavaScript 2015, which is value a k value, but we have a very interesting feature. It's if the key is no longer used by anybody and it's only stored in the weak map, they will be automatically removed by the system. So we will never have memory leaks. So we don't have to check if the key is still used by someone. And the key can be anything. Don't need to be a string. In this case, we are using this as a key, and each entry of the weak map stores the properties of one of these objects. So if we have 10 objects, we will have 10 entries into this weak map. One weak map stores properties for all the objects, and the key is the this value. We still need the extra function to keep the weak map private, but if we are using modules, we don't need this anymore, and the syntax is very, 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 very clean. Okay. Another interesting thing is that we can create mixins in a standard way. We didn't have previously a standard way to create mixins. We can do that, just showing the code. Why we can do that? Because classes are first-class citizens. So we can pass a class as a parameter, and we can return a class as a return value. Why? Because class are basically functions. Okay? So we can do something like that, where SC is a class. And then we can use this kind of code, which is applying a mixin. It's a new scenario that we have in a standard way. Previously, we had a lot of ways creating mixins in JavaScript. None of the ways really were working in the whole situations. And this way works in every situation, and is very, very, very simple to use. And modules, which is one of the new features. We have been using modules from some years. Now they start with CommonJS, later AMD. Okay, if you prefer CommonJS, if you prefer AMD, you will like this new module system because it takes the best of two worlds. Okay, gets the syntax very compact, support for cyclic dependencies, which is one of the strongest points of CommonJS, but it's similar to AMD because allows support for asynchronous module loading, which is very good in browsers scenarios. Specifically when we will have HTTP 2. This is the code. No, we don't have module.exports, nothing like that, just have an export. This is a module that exports three items, a const, a function, and another function, and we can import and use using that way. We can import the things that we need, not all. But if we use the asterisk, we import all the modules. So we can do whatever we need. Okay. And we have the default export, which is the preferred way to exporting methods, which means is the most important export, means the module itself, and it's using export default class. When a module uses the default export, when you import, you need to name the default export. Import my func from my func will import the default export of this method. Okay, and a module can use both kind of exports. In this case, the React Native module are exporting one default export, which is React, and image, text, and so on are named exports of the module. Why this? Because this is a very common pattern in JavaScript. React means the core, and the rest are optional dependencies of that module. Think in jQuery, $ will be the default export, and all the functions like Ajax, get, and so on will be named exports. Okay, so we have a lot of flexibility. Just a brief recap, we can do that in CommonJS, cannot do that in ECMAScript module system. Why? Because in ECMAScript module system, the tree of modules is static. It's not dynamic, so we can do that because for knowing which module we need to import, we need to run this code, and this is not allowed in the ECMAScript module system. Okay, is less flexible but can be optimized. And a last thing, promises. Probably you know promises because we have been using Signs of Time. Every JavaScript library has its own implementation of promises. jQuery has, Angular has, and so on library has. Now are part of the languages. A specification is called promises A+. Basically, no more callbacks. Promise is a task and it's a state. It's a promise of a task that we fulfill that will be done sometime in the future. No more pyramid hell, callback hell. It's that code. I've seen this code several times. So I say the people, you need to use promises to get off this code. So people start using promising are finishing with this code, which is not better anymore. So this is the promise pyramid hell, which is one of the anti-pattern, one of the most common anti-pattern when using promises, okay? And this is how we will use. Assume that we have a function that returns a promise by fetching a new URL using get. So we use the then to set the code to run when the promise is fulfilled, and we can use catch to set the code to run if there is an error running the promise. So that's the basics. It's very easy. But what happens if we want to have 3 consecutive calls, one after the other? So we can do that, but we are running into the pyramid hell. So in this case, into the then of the first promise, create a second promise, and in the then of second promise, create the third promise, and so on, so on, so on. And that works. We have the calls one each other, good, but we have the pyramid. How is the good way to do that? Is that. That is the correct way to do the things. The key is if the then method returns a promise, which is the case, notice the return that's involved. If the then method returns a promise, then the promise is unwrapped, and the next then method waits for the previous promise to finish. So this code is identical, behaves exactly in the same way, but it's absolutely flat. Some people are asking, okay, and what happens if we want to do the 3 calls in parallel? No problem, we can do promise.all. Promise.all is a method of promise that takes an array of promises and creates a new promise that is fulfilled when all the promises we have passed to promise.all are fulfilled. But the promises we pass in promise.all are executed in parallel. So in this case, we have the array, the 3 calls made in parallel. And in the final then method, which is the then method of the promise returned by promise.all, in the method then, we will have an array containing all the return values of each individual promise. So that is a very, very, very powerful method to handle our asynchronous code, and it's very easy to use. That's the way for creating that function we have seen. Just create a promise, new promise, we pass a function as a parameter. This function will have all the code, and that function always has 2 parameters. The first is the resolve, the second is the reject, and to fulfill the promise and pass the result to the then method, we use resolve, and to set an error, we use reject. It's very easy, and then we return the promise. It's a very, very, very easy way to create promises, okay? In the near future, that's approved, so that's sure that will be in ECMAScript 6. We will be able to do things like that using async await. Await will do an asynchronous wait for a fulfilling a promise. The key is the asynchronous. So when the code reaches an await, returns to the caller continues its execution, and when the promise is fulfilled, code re-enters and continues its execution after the await. So we have a full asynchronous code with no callbacks, with no passing methods, that looks like full synchronous code. Okay, and this will be sure in ECMAScript 7. And finally, just what to look next. First, start using ECMAScript 6 today. Take a look on the ECMAScript 7 proposals, which are on GitHub. Okay, there are all discussions are on GitHub, and you can look all proposals and what people is doing. Learn about reactive programming is very, very important, because all new frameworks that are trendy and the frameworks that probably will drive the future of web development, like Flux, Redux, Cycle, and even Angular 2, are heavily based on the reactive way of doing things. So web is turning reactive, literally. If you hate dynamic typing and want static typing, invest in TypeScript or Flow, which are 2 languages or two mechanisms to add static typing into JavaScript while preserving full code compatibility. Okay, in fact, Angular 2 is developed in TypeScript. Okay, and learn some functional language. Why? Because JavaScript is turning functional. A lot of new proposals are for functional features and so on. So I think that's very, very, very important for you to start using functional language. No matter one, you can choose Scala, you can choose F#, OCaml, Elixir, Haskell, whatever you want. But choose one and at least start practice with the fundamentals of functional programming, because web is turning also functional. So in my opinion, web is turning reactive and functional. So it's important, if we want to be on this game, we need to learn all these concepts. And that's all. So, questions? No? So, thank you very much.